I click back on this test point, you can see it's guard banded. All right, if you look up here at my as found and my as left measurement for the test point, and incidentally, in the MOX software, everything in the system is driven around the currently selected test point. So in the user interface, whenever you change test points, you're going to see all the information in here is everything around it. I always say the true document in MOX are test points, not data sheets. Data sheets is just a collection of test points, but everything in the system is centered around, the test points and what constructs them in their history. Okay, so now when I look at this test point here, you can see that for my as found, I used the Fluke 5522 calibrator, and that gave me a standards accuracy of 5 microvolts. And again, these were met spec instruments, just like I showed you with the pressure calibrator, right? Of course,
Right.
There are a lot more complex spec sheets because they have a lot more functions and ranges and all that. But anyhow, here's the actual accuracy is 5 microvolts. And then this is showing me that I used the 330 millivolt range, and these are the actual specs for that range of the calibrator. And then when I look at my as left data, I used the Fluke 5500 calibrator, and that was 15 microvolts. Okay, so when I look at my results up here, you'll see that my tolerance for my as found is just using the design tolerance because my TUR is 9.7 to 1. And my PFA is well under my target PFA of 0.8%. Okay, but when I took my as left data using that 5500, my TUR dropped down to 2.5 to 1, and my PFA is above my target PFA of 0.8%. Okay, now what's important about this is that MPS then automatically guard banded, and guard banding is optional in MPS. So if you don't want any guard banding, you can basically turn off guard banding. And if you do want guard banding, MPS supports 3 methods for guard banding. It supports the old RP10. If you're familiar with mudcats, for instance, it used the RP10, which is just a fixed percentage of the EMU will be the guard band amount. Or you can do the Z540.3, and we use the RP18 iterative statistical method to actually determine the guard band multiplier. So what it will do is it will keep adjusting the guard band multiplier until it finds the guard band multiplier that just returns it to the target PFA. So you'll get just enough guard banding to get you back to your target PFA. So you can see that here, right? With the design tolerance, our probability of false accept was 1.08%, and then with the guard banding, 0.8%, back to our 0.8%. And the third method is the RSS method, and that's used a lot by the DOE folks.